Good afternoon friends. Today we are going to study about the design of the gearbox. To construct or to design the gearbox, we have to study about the laws of step regulation of speeds in multi-speed gearbox, right? So what is the function of the gearbox? During the running of the vehicles, we have to fluctuate the speed of the vehicles according to the need, right? As per discussed in our last lecture, that if the slopey area is there, then we have increased the torque and as decrease the speed. But whenever the vehicle runs on the straight road, then we are not required the high torque. So the vehicle runs at the low torque and high speed, right? So due to the fluctuation of the speed and torque, we made a gearbox. So during these changes of the speed, during the changes of the speed, or you can say that during the changes of the gears, there are different kind of spindles are available in the gearbox. So the regulation of the speed of the spindle, right, we have to follow the laws of the step regulation of speeds in multi-speed gearbox. There are three laws. First is the arithmetic progression, second one is the geometric progression, and third one is the harmonic progressions, right? So in the arithmetic progression, when we are taking the arithmetic progression, right? So what is the law? What is the definition of the arithmetic progression? So the condition of the arithmetic progression is the difference between two consecutive spindle speed remains constant, right? If you are taking a second and third spindle, then the speed of this difference of the speed of the spindle number 2 and spindle number 3 is always constant. As if you are taking the spindle number 3 and spindle number 4, right? Take an example. If this is the spindle number 1, right? This is the spindle number 1. Next spindle number 2, spindle number 3, and spindle number 4. If you have the four different kind of spindles, then the difference between spindle number 1 and spindle number 2, what is the difference? The difference of the speed, right? The difference of the speed of first spindle and second spindle, and also the difference of the speed of spindle number 2 and spindle number 3 is always remains constant, same as the difference of the spindle number 3 and spindle number 4, right? Means the difference between all the consecutive spindle speed remains constant is the condition of the arithmetic progression, right? Now for the geometric progression, then the difference of the ratio, right? Ratio means the ratio of the spindle speed 1 to ratio of spindle speed number 2, means speed of the spindle 1 to speed of the spindle 2 is the ratio, right? Now we are going to take the ratio of spin 2 to 3, right? Means this ratio is remains constant always, right? So the ratio of the consecutive spindle speeds is always remain constant in the geometric progression. Now if we are taking the harmonic progression, if we are taking the harmonic progression, then this is the spindle number 1, spindle number 2, spindle number 3, and spindle number 4, right? Now we have to take the reciprocal of the spindle speed. If the spindle speed of the spindle number 1 is n1, for the n2, n3, and n4, right? So four spindles are available, so the spindle speed is n1, n2, n3, and n4. Now we have to take the reciprocal of all. So reciprocal of n1 is 1 upon n1, reciprocal of n2 is 1 upon n2. So the difference between two consecutive spindle speed, but what, the reciprocal of the spindle speed is remains constant. So as per the harmonic progression, the difference between reciprocal of two consecutive spindle speed means 1 upon n1 minus 1 upon n2 is equal to 1 upon n2 minus 1 upon n3 is equal to 1 upon n3 minus 1 upon n4, right? All the values you get is equal. So this is the three laws. Now the comparison of the all arithmetic, geometric and harmonic progression for the design of the gearbox. Now, as per we discussed, the definition of the arithmetic progression is in the arithmetic progression, the difference between any two successive spindle speed is constant. Geometric progression, in the geometric progression, the ratio of any two successive spindle speed is constant, and in harmonic progression, the difference between reciprocal of any two successive speed is constant, right? Second, z spindle speed. If you want to find the z number of spindle, z speed of the z number of spindle, right, then you have the equation is for the arithmetic progression nz is equal to n max minus n minimum divided by z minus 1, right? Means the maximum spindle speed minus minimum spindle speed divided by number of spindle, means which number of spindle speed you have to find is z minus 1, where in the geometric progression phi is equal to maximum spindle speed to divided by minimum spindle speed whole raised to 1 minus z minus 1, 1 upon z minus 1. And for the harmonic progression nz is given as and maximum spindle speed divided by 1 minus z minus 1 c into n max, right? Now for in the arithmetic progression and geometric progression, the spindle speed for the arithmetic progression and geometric progression is used for the high spindle speed range, whereas the harmonic progression is used for the low spindle speed range, right? So this is the difference, or where we can use the arithmetic progression, geometric progression and harmonic progression, right? Now the design procedure of the gearbox. What is the step we have to follow to design the gearbox? This procedure is for only for the sliding gear type gearbox, right? For the designing of a step drive, following informations are necessary. First is the highest output speed, means the spindles, what is the maximum spindle speed and max we have to we required the lowest output speed, means the n minimum. We have the number of steps, for what steps we have to design the gearbox. This is the information what we have we required, or what is the necessary informations. Number of stages to achieve the required number of speeds, right? These are the required information what we have necessarily. Second step is backup of speed steps. The number of steps should be so selected that it can be broken into multiple of 2 and 3, right? Thus the selected value of z means the number of spindle should be 6, 8, 9, 10, 12, 14, 16 and 18, right? Now third step is the structural diagram. This structural diagram is the important thing to design this gearbox. Whenever we want to design the gearbox or to construct the gearbox, if we have the structural diagram of the gearbox, then we can design easily. Why? Because the structural diagram gives the information about the number of shafts in the speed box, number of gears on each shaft, the order of changing transmission in individual groups to obtain the desired speed, transmission range and good group characteristics, right? Means the number of shafts in the speed box, how many shafts are using or how many shafts are required to construct the gearbox, how many gears are attached to the shaft, right? Means how many transmission system is available on each shaft is given by the structural diagram. The order of changing transmission in individual group to obtain the desired speed and transmission range and the good characteristics. So this all the informations provided by the structure diagram. Now, while drawing the structure diagram, following points should be considered. Whenever we want to design or whenever we want to draw the structure diagram of a gearbox, we always remember the number of gears on the last shaft should be as minimum as possible. Why? Because at the last shaft means at the last stroke we required less torque but the high speed. So we can't afford the high stress produced on the last shaft, right? So number of gears on the last shaft should be minimum as possible. The speed reduction between the spindle and preceding shaft should be as maximum as possible, right? Number of gears on any shaft should be more than 3. It can be 4 in exceptional case, right? Imax into Imin is equal to 1 is for least radial dimension of gearbox. This is possible by making the axis of adjacent shafts coincidence. Imax into Imin is equal to 1 is possible when the maximum speed reduction equal to the maximum speed increase, right? But considering the importance of the reduction of axial dimension of gear in machine tool with a traversing spindle's head, the above points does not favor it because small axial dimension of traversing units are critical. Structural formula represented by this special form of graphs is called as structure diagram. Method of drawing structure diagram, right? Now we are going to study about the method how can we draw the structure diagram. If n is equal to no, number of transmission groups, then draw n plus 1 vertical lines, right? If we have the n is equal to 3, right, 3 transmission groups, then we have to draw 4 vertical lines n plus 1, right? So this is the 4 vertical lines have been drawn, right? Here the first vertical line represents the transmission from the motor shaft. So this first shaft is directly connected to the motor shaft and transmission is done with the help of motor or external power. And the rest represent means these three is represent the transmission group of the speed box. Means during the transfer of the speed from the first to the other, then it will reduce or increase the speed as per requirement. Draw an any of horizontal lines intersecting the vertical line at a distance of log phi from each other. The number of horizontal lines are equal to the number of speed steps, right? Means as per the z we have to draw the horizontal line, right? If we have the z is equal to 3, then we have to draw the 3 horizontal line. The spacing between the horizontal line should be equal so that interval between the spindle speed is constant. So the distance between all the horizontal lines should be equal for to contain the spindle speed. In practice, the distance between the adjacent horizontal line is taken equal to the phi but not log for convenience, right? Now, third step is draw a line joining the first shaft of known speed and the second shaft for calculated input speed. The speed reduction between the first and second shaft is usually through the belt drive. Fourth step is from the second shaft at the input speed point of diverging line joining the third shaft. The number of lines will be equal to the number of transmission, right? The maximum spacing between the line on third shaft will be according to the calculated transmission range between these two shafts. Say 5 for the second, is the 5, for the third is the 5 raised to 2, right? For the fourth is the 5 raised to 3, and so we can take the equation is 5 raised to n minus 1, right? So this is the equation. Now fifth step is from the third shaft for all group draw the diverging lines having maximum spacing on the fourth shaft as per calculated value of transmission range of groups. Right, now we have to draw the speed chart. The speed chart depicts the transmission ratios. The structural diagram depicts only range ratio, so speed chart must be plotted to depict the transmission ratio. The horizontal line correspond to transmission ratio I is equal to 1. So no speed, because we have taken this tap speed is equal to 5 raised to n minus 1. 5 raised to n minus 1. So if we are taking the I is equal to 1, so n is equal to 1, so 5 raised to 1 minus 1 is equal to 0. So there is a no speed. Line inclined upward corresponds to the transmission ratio if I greater than 1, means the increasing in speed. If we find the line inclined downwards correspond to the transmission ratio if the value of I is less than 1. While plotting this speed chart, it is desirable to have minimum transmission ratio, maximum speed reduction in the last transmission group, the remaining shaft run at relatively higher speed and so subjected to less torques. Now the kinematic diagram. A kinematic layout is a pictorial representation of the gearbox describing the arrangement of the gears, right? As per the output of the structure diagram and speed chart, we can plot the kinematic diagram as per shown in the figure, right? With the help of information of the kinematic diagram, we can justify that the how many shafts are used in the gearbox and how at each shaft how many gears or how many transmission change, right? Means the how many times the speed and the torque can be varied at the shaft. It provides the information like number of stages, number of shaft uses, number of gear pairs and its arrangement, right? So this is the kinematic diagram. Now ray diagram. A ray diagram is a representation of the structural formula. It provides the information such as speed in each stage, the transmission ratio in each stage, the total number of speeds and its values. As seen in a figure, right? This is the figure of the structural diagram, or you can say is the ray diagram. As seen in a figure, the maximum speed and the minimum speed both are higher for the shaft. The required smaller size of shaft due to reduced torque. But as the second figure, the maximum speed, as the maximum speed means this is the maximum speed, right? And this is the minimum speed. So we can denote as a n. M is the maximum speed and n is the minimum speed. So as per this figure, we can take that the maximum speed and minimum speed both are lower, which require larger size of the shaft due to the increased torque. The version indicate in the third figure is middle situation. One will definitely prefer the version B, but if the machine cost of shaft is not criterion, the version A is preferred, right? So this is the ray diagram where we can find or we can decide the which version we have to follow according to our maximum speed and the high torque whatever we require, right? So this is the step, or this is the all steps we have to follow to design or construct the gearbox. In our next lecture we will study the examples of the gearbox.